The area under the PK curve, or AUC, is often needed as an important PK metric to link with the pharmacodynamic effect. In this video, we will see how the AUC can be computed within a PK model file and how it can then be used as an output of the applications of the Monolix suite. Let's first have a look at a simple PK model written in Electron. A one-compartment model is defined with PK macros in a block PK with an oral absorption and linear elimination. The variable for the drug concentration is named CC. Note that this model could also be written with a single macro PK model or with ODEs. The AUC is computed by integrating the concentration over time. This can be done simply like this by defining the variable AUC in a block equation with the derivative of AUC equals to the concentration. I will now show several ways to use this variable as an output with applications of the Monolix suite. If I want to quickly simulate this model in ML Explorer, I just have to add some parameter values and dosing information, and I can include the variable AUC in the list of prediction outputs together with the concentration CC. After running, I get these two plots with the simulation of CC on the right and AUC on the left. The prediction values can be exported with task export table. If I want to estimate this model with some PK data in Monolix, I can define AUC like here as an additional output available for post-treatment with table. Note, however, that in this case, including the computation of AUC in Monolix will slow down the estimation because the PK model will have to be integrated rather than simulated with the analytical solution. After estimating the model, the individual predictions for AUC can be found in the result folder of the project in the file tables.txt with the same observation times as the PK data. If I also want to get the AUC values at different times than the observation times from the dataset, for example the final AUC after a long time, I should use Simulix with the R package MLXR to simulate the model based on the parameters estimated by Monolix. For example, on this R script displayed in RStudio, the AUC item 1000 is simulated based on the Monolix project that I have just shown with the individual parameters estimated by Monolix and is printed here for all individuals. Note that even if the definition of the AUC was not included in the model associated with the Monolix project because I didn't need it at that time or to avoid slowing down the estimation, it is possible to add it just for the simulation with Simulix with the argument add lines, like on this example. The two lines defining the AUC with the initialization of the variable and the ODE are given to Simulix with the argument add lines as a formula to add to the model in the block equation. Finally, the formula can be adapted to limit the computation of the AUC to a given time period. For example, this piece of model computes the partial AUC between times 50 and 100. The formula is a bit more complex than before. We define the intermediate variable AUC50 that contains the AUC value until the time 50. With the if-else statement, AUC is computed as the integration of CC before time 50 and as a constant variable after the time 50. Similarly, AUC 100 is computed as the AUC value until the time 100. At the end of the simulation, the variable AUC 50-100, defined as the difference between AUC 100 and AUC 50, will contain the partial AUC. This concludes this video, and you can find the formulas on our online documentation. See you next week!